sand again. We need to do a part 2 because I ran out of time. Sorry about that. I got cut off when I was talking about the object going up and coming back down, and I was trying to convince you. I was just trying to convince you that if you throw an object up in the air, the time it takes for it to be released and travel to its apex, which is the very top of its path, at top of its trajectory, it's the same amount of time for that object to go back down to where it was released. You can try this with any object around the house, and you'll see that it's true. It's just a physical fact. Convince yourself of it. You'll be happier for it. So in that last problem, all you needed to do was multiply your 1.85 seconds by 2, and you're going to get your answers 3.70 seconds. That's how long it takes for the ball to reach the ground, assuming it's a perfectly horizontal ground. Right. So let's go on to problem E. This is on the next page. Problem E. I gotta find problem E. There's problem E. Yeah, no, don't save. What is the maximum height of the golf ball during its trajectory? Right. So we know quite a lot of stuff. This is very much like the problem when we were trying to find the amount of time it took for the ball to reach its apex or top of its trajectory. We know that, well, first of all, what are we looking for? We're looking for the height. Ooh, let me use a different color. Asparagus. Perfect. The maximum height is going to be delta S. We want to know what delta S is. Question mark. So, we know the initial velocity in the y direction. That's going to be 18.1 meters per second. And I know that from a previous problem. That was the answer to the previous, I think it was the first problem. Yeah, part A. I know that the final velocity, VF, in the y direction, on its way up, is going to be 0 meters per second. Because at the very top of a path, if you've got an object that's launched up in the air and it comes back down, that was okay. When it gets to its very peak, at that point, in the y direction, its velocity is 0. So I know at that point, the maximum height it's going to get, well, that velocity at that point, well, that's 0. And what else do I know? I know that the acceleration, I could call that g if I wanted to, but I'm just going to keep it as acceleration right now. We know what we're talking about here. I'm sure we do. There it is. Great. So how do I solve for delta S? Is there some kind of equation that can help me? Help me now. I want you to help me. Yeah, there is. And it's an equation that we used before. You can use actually a couple equations if you want to, since now we know delta T as well. But I'm just going to use this equation because it has fewer variables. So you might remember this equation from our acceleration unit. VF squared minus U squared over 2A. Now, we want to solve for delta S here, so everything's in its place. All we need to do is plug in our numbers, and we are going to rock, because this is a 0. That's going to be 0 there. It's canceled. It's no mas. And this U is 18.1 squared. This A is going to be negative 19, or negative 9.81. So our final answer, once you plug it into your calculator, is going to be 16.7 meters. You'll see that the units cancel out, just so this is meters. And that's our peak right there. That's the height that you get. Next question, how far does a ball travel when it hits the ground? So this is after it's gone this whole time in the air. So, long time ago, I remember telling you that for a horizontal velocity, well, we're thinking about horizontal velocity here. We're thinking about horizontal things because we want to know how far, which when we mean how far, we're looking in this direction right here. How far is this ball going to go? Okay. when it hits the ground. Actually, this is kind of vague. It should say something like, what is the final position? So if I had to rewrite this question to be clearer, I would erase this. What is the final position of the ball when it hits the ground? Or I could say, what is the displacement? Oh, it's even better. I'm just revising like crazy now. What is the displacement? That's even better. Oh my God. What is the displacement? I love taking incorrect physics problems and changing them into more correct and better descriptions for you. Okay, right. So what is the displacement of the ball when it hits the ground? So what's the displacement? So I'm looking for this from here to here. What's the displacement? And for this one, I need to know, first of all, what's the horizontal velocity? Well, we figured this one out. This is awesome. We already figured this one out. And it was 28.9 meters per second. We figured this one out a long time ago. In part B. I think you can see where I'm going with this, but just in case you don't know, the thing that's really important to us now is that the time it takes for the ball to travel here. Since we know the horizontal velocity, all we have to know now is how far it's going to have that horizontal velocity, right? So, I'm sorry, how long it's going to have that horizontal velocity. Because that will tell us then the distance. If we know the speed or the rate it's going and we know the time it travels that rate, we can figure out how far it travels. So our delta t, our total time, was just what we found at the beginning of the video, which was 3.7. That is a 3, I think. 3.70 seconds. All right. And from our equation of velocity equals delta s over delta t. So this is our initial velocity. That's going to stay as our velocity. It doesn't change, actually. Because we don't care about wind in this situation. We're pretending that it's not in an environment with wind. Weird. But that's the problem. Okay. So all we do is take v, in this case it's this value right here, times delta t, and this will get us delta s. So v is 28.9 meters per second. The time is 3.70 seconds, and that'll give us our displacement, which is 107 meters. Oh, yeah. All right. Hope you had fun. Good luck with the other problems. They're very similar to this. Think through them. Solve them using your brain. I know you can do it. Bye.